Alright, this is the last standard that we have to cover in Unit 2. The proficiency part of the standard, I can write the equation of a quadratic given its zeros or its vertex. I can write the equation of a polynomial given complex roots and can explain the fundamental theorem of algebra, is the 4 type. Our last standard focused on working backwards and how to find equations of quadratics by hand given particular information. All this time we've been working on solving and finding the zeros. Now our goal is to use the answers to get to the original equation. So before, every time we've come across a quadratic, it's been solving. So we've solved it using completing the square, we've solved it by factoring, we've solved it by the quadratic formula. Now we're going to work backwards. So we're going to use the answers. I'll give you the answers, and then we're going to end up working from the answers all the way back to what the original equation was. There are 2 types of information that can be given to us about a quadratic. They are the vertex and the x-intercepts. I told you several times, or we've talked about several times, that the vertex and the x-intercepts of a quadratic are considered the most important points, or that's at least what I call them. They're key features. They're where important things happen. The vertex is where either the highest value happens or the lowest value happens. If you're talking about the flight of an object, it'll be the highest height that it reached. With x-intercepts, if you're talking about the flight of an object, you're talking about where it started and then when it hit the ground, where was it at again. And so in real life, those points are part of the most important values that you might find, but also they're key features because everything builds around where the x-intercepts are and where the vertex is. Okay, so we have 3 quadratic forms, and this is just a reminder of what these look like. Standard form is y equals ax squared plus bx plus c. Vertex form is y equals a times x minus h squared plus k. And intercept form is y equals a times x minus p times x minus q. So these are the forms. All 3 of these are quadratics, but they are all written 3 different ways based on the information that they give you, or the information they supply. So the type of information you're given will direct you in how to start finding the equation. So, for example 1, I'm going to ask you to write the equation of a quadratic given a vertex of 5, 2, and a point on the curve of -2, 11. Okay, so give us 2 pieces of information. Almost always you're going to have to be given 2 pieces of information in order to make this work. They give you a vertex and a curve. Now because they give you the vertex, that indicates what form you're supposed to use. So I'm going to use the vertex form to start my problem off. And I have 4 numbers. Now these 4 numbers do plug into 4 different places. However, you have to be careful that you identify what each of these numbers, or what variable each of these numbers pair with. So a vertex of 5, 2. This is called vertex form because HK is the vertex. So in this case, 5 and 2, those are my coordinates of my vertex. Those are the values of my H and my K. And then a point on the curve, -2, 11, this is just representative of any point. So this is my X and this is my Y. Notice I have H, K, X, and Y. I don't have A. So we've done this a few times in some other scenarios. We're going to plug all these back in and solve for A. And you actually did this in your catapult project. You did something very similar to this. So I plugged in 11 for Y, -2 for X, 5 for H, and 2 for K. And I'm going to go ahead and simplify. Now when you simplify, I always do this part first. So -2 minus 5 gives me -7. -7 squared is 49. So that's 49A. And I know up here it was A times 49, but I moved the 49 in front because I don't want to suggest to myself that I add 49 and 2 together, because 49 and A are being multiplied. I can't add those together yet. So now I'm solving for A. I'm going to move 2 over. So I get 9 equals 49A. And then I'm going to divide by 49. So A is 9 over 49. Okay, now that I'm not done, but I did find my missing variable. So your final answer, excuse me, when you write it, will be writing it so it looks exactly like the vertex form, except you're going to plug in A, and you're going to plug in H, and you're going to plug in K. Now the reason we don't plug in X and Y again is because this X and Y have to represent every point on the curve, not just one specific one. So this is my equation based on the information that was given to me. Okay? We're going to do something similar with intercept form and standard form. So, for example, 2 using intercept form. Same wording. I'm not going to make you write all this wording again, but your question would say something like, write the equation of a quadratic given an x-intercept of such and such, another x-intercept of such and such, and then they have to give you a random point that it goes through. So, same type of deal, but the information that I'm going to give you is that it goes through the point, let's go -5, -3, and you have 2 x-intercepts. Let's go with x at -3 and 2. Okay, because the information that I'm giving you about this quadratic that we're supposed to write the equation for is 2 intercepts, we're going to use the intercept form. Okay, so I'm going to go ahead and write that intercept form out. Now again, I have 4 numbers. Those get plugged into 4 different places here. The random point that's given to me that's on the curve is always your x and y. And then the intercepts, those are my p and my q. So I'm going to go ahead and plug those numbers in where they go. -3 is my y. -5 is my x. P is -3. So really that's a +3 because you're subtracting a negative. -5 is x again, and then q is 2. And then I'm going to go ahead and simplify. -5 plus 3 gives me -2. -5 minus 2 gives me -7. -2 times -7 is 14. And so my A is -3 over 14. Then I'm going to go ahead and plug this back in to the form, so it looks like a quadratic equation, by plugging in my A value, my Q value, and my P value. Again, the X and the Y have to stay in your final answer because it represents every point on that curve. Okay, example 3. Okay, so we've done one example where they give you a vertex and a point, so you have to use vertex form. We did another example where they give you a point and 2 x-intercepts, so we have to use intercept form. So the last one, we're probably going to end up using standard form. Now this is when you write the equation of a quadratic, and instead of me giving you specifics or some of the key information like x-intercepts or a vertex, I'm just going to give you 3 points on the curve. So 3 of these xy points. Okay, so these 3 points are going to be -3, 4, -1, 10, and 4, -6. Okay? When you're given 3 points, where 2 of them are not designated like a vertex or an x-intercept, but you're just given 3 points that lie in the curve, we actually have to use the regression feature of our calculator that we've used before to come up with our equation. So you might want to draw a line here. We're going to write some steps. You'll need a graphing calculator for this type of problem. Okay. So for this type of problem, you would start by hitting the Stat button. So I'm going to write out the steps here for you too. Stat button. And you're going to do the Edit feature. Okay. Stat Edit. If there's stuff in your list, you clear it out. So clear, clear. Okay. L1 and L2. In L1, I'm going to put all my X values. And then in L2, you're going to put all your Y values. Okay, so -3, -1 and 4, 4, 10, and -6. Alright. Then you go back to Stat, and you go to Calc menu. So Stat, Calc, and then we want the quad regression. So go down to that. And then you have to input it as an ordered pair. So quad reg L1, comma, L2, and then we have to enter. So to put in L1, we do second 1, comma, second 2 for L2, so it matches what I should see here. Hit enter, and then it gives you your A, your B, and your C. And then that's what we're going to copy down. Okay, so my A is -0.89 x squared. My B is -0.54. And my C is 10.34. And that's your equation. Alright. Okay. I'm going to save the 4 type problems for probably another day. We might do them tomorrow. Yeah, or I might just include it. Yeah, we'll do it another day. Alright, so focus on example 1, 2, and 3. You have one example of each. Make sure you have this done and ready to show me tomorrow. And we'll go from there.